Hi, I'm Prashant,
Hi, I'm Madeline.
Hi, I'm Alexandra.
and this is our project on the Great Pacific Garbage Patch. So we have a few key points we're going to discuss today. One is, what is the Great Pacific Garbage Patch? And two, why do we care about it? And what kind of problems are causing the Great Pacific Garbage Patch, and what can chemical engineers do to solve them? So identify three key problems, one being the macroscopic large plastic debris, such as plastic bags. Two is the microplastics, which are degraded forms of the larger plastic debris. And three is the fishing nets and fishing gear, which are spread across the ocean. And at the end, we're gonna have a small concluding portion where we summarize everything we talked about.
Yeah, so what really is the Great Pacific Garbage Patch and what are we doing to solve it? So as you can see from the picture, the Great Pacific Garbage Patch is a large region in the ocean that is just consumer trash, fishing nets, and other plastic goods that have accumulated over hundreds of years. So it is defined by National Geographic as this area of large biomass. And if you'll move to the next slide. And so there are two portions of it. We have the Western Garbage Patch and the Eastern Garbage Patch. And so these actually are two separate patches due to the way that wind currents move and the way that the ocean sort of shifts and changes over the years. And so this is why it's a big problem, because it's constantly moving. And so it's very difficult to contain. And as chemical engineers, it's our job to figure out what we can do to contain this. Just for size reference, it's about 2 times the size of Texas, or 1.6 million square kilometers. 92% of the patch is comprised of plastic that's larger than 5 millimeters. So that's kind of your larger plastic, shampoo bottles, plastic bags, fishing nets, the sort of thing that we have to act fast to fix before it gets to become microplastics. So why does this matter to us as consumers and us as chemical engineers? Well, we add about 1.15 million metric tons of plastic into the ocean every year. 80% of this is from our land activities. You know, every time you go to Target and you dispose of a plastic bag, it has a chance of ending up in the ocean. Toothbrushes, shampoo bottles, everyday objects that we use as consumers, they have a high chance of ending back up in the ocean. 20% of this is also from our marine activities. So all of our fishing and all of the ways that boats also dump trash into the ocean. You know, you have your concept of ghost fishing, which happens because of illegal fishing and weather issues, you know, so those fishermen who are engaging in catching animals that are prohibited, such as certain sharks and dolphins, they dump the nets rather than collecting them back to dispose of any evidence. And so these get caught in the ocean and end up killing animals when they get trapped. And then we also have the deterioration into microplastics, which is incredibly difficult to remove. As we'll talk about later, they're microscopic and oftentimes not even visible to the naked eye. And then we also have the issue of biotoxins and bioaccumulation. You know, plastic pollution creates a lot of issues when it comes to the consumption by animals, moving up the food chain. You know, when you eat a fish, you're not expecting to eat that plastic, but oftentimes it is a byproduct of the pollution we have. And this actually costs the world 13 billion a year to micromanage. So what problems are we solving as chemical engineers, and how are we going about doing this? The first problem that we're looking to solve is plastic bags. We're going to increase the biodegradation of plastic, and we're looking to keep it out of the water. Plastic bags add 100 million barrels of oil into the water sources. And so as this is incredibly difficult to remove, we're also working as chemical engineers to contain our additions. So we're finding cost-effective ways to reuse the bags, reduce the chance of them ending back up in the ocean. Additionally, these appear as jellyfish and sea creatures to animals who think that they're their prey. And so when they consume them, it destroys our food chain, and it also increases sources of things like dioxin, which is an endocrine disruptor. So it not only destroys the marine infrastructure, but also the resulting consumers who consume those marine animals. So how are we stopping the growth of the patch? The first thing we're doing is switching to the concept of producer responsibility rather than consumer responsibility. We oftentimes hear the phrase reduce, reuse, recycle, and that's great. But when we have a lot of bylaws and national organizations that dictate how trash and recycling can be designated, it becomes very difficult to make sure that we have the largest percent of recycling occurring. And so you have universities, University of Oklahoma and University of Wisconsin are working on polymers with the Department of Energy that actually can be reduced into monomers that just decompose straight into carbon, methane, water, less harmful for the environment. And so when they do end up in the water, we're making sure that they're not lasting there a long time. The other thing that we're working on is at UC Berkeley, they're turning bags into adhesives. So they're kind of reducing that practice of fossil fuel burning and instead adding an OH group to these plastic bags that will enable them to become transportation lubricants, manufacturing polymers, and other chemicals that we work with. You can see in the diagram through the process of catalytic upcycling, we're able to take a lot of our everyday consumer goods and transport them back into another reusable item. And the biggest way that we are playing to consumers to make this happen is through the Ocean Cleanup Project. And so this is the concept of, creating consumer goods from this recycled plastic that raises awareness. We saw this with plastic bags or with plastic straws, with Save the Sea Turtles. That was a huge thing. You had countries like Hawaii who switched to only using recycled biodegradable plastic for their straws, and you had countries who banned straws altogether. And so this, in collaboration with the public, has made it so that we're able to make sure that on both sides, consumer and producer, we're reducing that use.
Okay, the second problem which we identified was the problem of microplastics. So when plastic debris, such as plastic bags, are left in the ocean, they degrade into much smaller particles. And we have an example here with the small particles compared to a human finger, but they oftentimes get smaller than that and become even microscopic. And these small microscopic chunks become almost more dangerous to marine life than the larger debris itself, because they can, beyond simply being a danger to inhale or to consume, they become dangerous to even be near, because microplastics have a proclivity to collect organic toxins, such as metallic toxins like arsenic, beryllium, cadmium, mercury, lead, things which are almost universally toxic to marine organisms. So the main problem with microplastics is pretty obvious, is that they're really small. They're very small, and there's a lot of them in this really large ocean area, such as the Pacific Garbage Patch. So the problem becomes, how do we filter out such small things in such a large area? And one of the most promising solutions is being developed by researchers at the University of Adelaide in Australia. And they're using carbon nanotubes to filter microplastics. Carbon nanotubes have a really particular coiled structure, and in addition to being extremely small, so they are really good filtering materials. Researchers have also figured out that by adding chemicals such as manganese to the carbon nanotube structure, they can increase the metallic character of the structure. And since a lot of these organic toxins are metallic based, such as arsenic, lead, mercury, the small magnetic character can increase the carbon nanotube's ability to filter these microplastic these microplastic waste. So now there's two main problems faced by chemical engineers, and they are: how do we produce a sufficient amount of nanotubes to make a significant impact on the microplastic waste in the Pacific garbage patch? Carbon nanotubes are very expensive to produce, and if we're using current technology, we can only produce small quantities at a time. So we need to figure out how to upscale this process, how to optimize production methods to make more of these nanotubes so that we can deploy them into larger areas such as the ocean. And secondly, we've already figured out how we can use manganese to help the effectiveness of these carbon nanotubes, but how else can we alter the structure to make these nanotubes even more efficient? There's so many toxins right now which we still don't have adequate means of collecting, and it's very possible that we could add some form of something to the structure of the carbon nanotubes to make them efficient at doing just that.
So the last problem we're going to discuss is fishing nets and gear found within the Great Pacific Garbage Patch. Over 46% of the plastic and trash found within the Great Pacific Garbage Patch is made up of fishing nets and gear. And fishing gear can include hooks, lines, baits, and lures. Fishing nets and gear only make up a total of about 10% of all ocean plastics, which is significantly lower than the percentage found in the Great Pacific Garbage Patch. And one of the main reasons that all of this fishing gear and nets are ending up in the ocean are often due to accidental or voluntary and deliberate gear losses. This can happen when fishermen often don't need the fishing gear and nets anymore because it broke, or they simply don't need it anymore, or because it fell off overboard. Fishing nets are most likely to occur within the garbage patch because of its flotation capabilities, that the fishing nets float, allowing other larger plastics or microplastics to hook on and float on top of them, creating one giant patch. And however, from all of this fishing gear and nets winding up in the ocean, there's several negative effects that come with it. So first, over 100,000 marine animals are strangled or injured by plastics, specifically fishing gear and nets, each year. This unfortunately can be due to animals getting stuck within the fishing nets or other fishing gear such as hooks and baits injuring the animals. And it can even be caused by the microplastics being latched onto the fishing net and gears the animals can consume, injuring themselves. 86% of the mega and microplastics found within the Great Pacific Garbage Patch are carried by these fishing nets. And that's because, again, the fishing nets can act as a flotation device to carry the other plastics into the ocean and onto the garbage patch, making it really easy for animals to get injured by all of these plastics. But there are a few solutions that not only chemical engineers can do, but the general public can do as well. So first, chemical engineers can do, through research and development, chemical engineers can help find a solution. One of the biggest solutions they have developed is by creating fishing nets with the fiber Dyneema. This fiber is high strength along while being lightweight and is designed to reduce the amount of animals being trapped within the nets. It is also used with very few chemicals that have high toxins, which reduces the risk of toxins being able to get into the ocean and creates a healthier environment for marine life to live in. Other things chemical engineers can do is to help research and find the best materials and plastics that fishing gear and nets can be made from. This will not only allow fishing nets and gears to be more sustainable and biodegradable, but it will also allow them to maintain their high performance. So this can include using non-toxic metals for fishing weights, such as not using lead, which can be toxic, and also finding ways to create biodegradable monofilament fishing lines and ropes. Another way chemical engineers can help reduce the amount of fishing nets and gear within the ocean is to start back at the production of them in the production line. So finding ways to reduce the amount of excess materials and waste in the production of fishing nets and gear to prevent any unnecessary waste from winding up in the ocean. As for the general public, there are several things that they can do as well to help prevent fishing nets and gear in the ocean. This can include practicing eco-friendly fishing techniques and using eco-friendly fishing equipment, such as biodegradable fishing line, as seen in the bottom right-hand picture. Also, making sure to keep your fishing gear in check both on and off the boat and both on and off the water to make sure that you don't lose any fishing gear unintentionally. And last, to make sure to practice a more sustainable lifestyle by using more reusable products and less plastics. So our actions over the next 10 years will determine the state of the ocean for the next 10,000 years. So if we don't aim to start making an impact to start reducing the amount of plastics within the ocean, it soon might be too late to do anything about it. So in conclusion, today we discussed what the Great Pacific Garbage Patch is, the problems causing the Great Pacific Garbage Patch, and the impacts that the problems we are having on the ocean is the Great Pacific Garbage Patch is having on the ocean, and what chemical engineers are doing to solve these problems and to reduce the size of the garbage patch. So without the solutions of chemical engineers, and what they have to reduce the impact and size of the Great Pacific Garbage Patch, the effects will soon be irreversible. And here are our references listed below. Thank you.